Okay, I'd like to talk to you guys about how to figure out how many bonds an atom will make. We're going to be talking specifically about the atoms that are contained within our macromolecules: carbon, hydrogen, oxygen, nitrogen, and phosphorus. There are more. Remember I said sulfur yesterday, and selenium is another one, which we won't get into. But what I want you guys to understand is that in the periodic table, each of the columns have similar chemical properties. And we can tell you how many electrons are in its outer valence shell by the row that it's in, or the column that it's in, sorry. So if you look at the first column, there's 1 electron in the valence shell of all of these atoms. There's 2 electrons in the valence shell here, and then we're going to skip over this center, and 3 electrons available here, 4, 5, 6, 7, and 8. The ones with 8 electrons in its valence shell have a stable octet, which means they don't bond with other elements because they're happy. They've got a stable octet. Helium actually has 2 electrons, but because it only has that one outer valence shell, most of them will go to the next one. Okay, so let's take a look. So if I have 1 electron in my valence shell, and I'm hydrogen, I'm actually going to be able to either give that electron away to somebody else to share it. I'm going to be able to donate it in an ionic bonding situation, or I can bond with another atom of that has 1 electron in its valence shell. Okay, so I want 2 or none. Okay, let's scoot over here to carbon, and carbon has an atomic number of 6, which means that there are 6 protons in its nucleus. And in a neutral atom, the number of protons equals the number of electrons. So there's 2 electrons here, and then that means since there's 2 there and we need 6 altogether, there's 4 in its outer shell, which means carbon actually has 4 empty spaces to fill in its valence shell. Okay, and that means that carbon can make 4 bonds. So typically you will see carbon that looks like this. It can have 4 bonds. Okay, next thing I want you guys to understand is, well, let's look at hydrogen that way. Hydrogen can actually make 1 bond. Okay, oxygen, if you look at oxygen here, oxygen has an atomic number of 8, which means in its nucleus there are 8 protons. So if I follow the rule, I can have 2 electrons in the inner shell, and that means there are 6 in its outer shell, which means I can take on 2 more electrons so that I have a stable outer shell, a stable octet. And so oxygen will typically have 2 bonds. Okay, sometimes the bonds are double bonds with carbon. Sometimes they're one with hydrogen and the other one with hydrogen. That's our water molecule, our H2O. So oxygen can have 2 bonds. Okay. Nitrogen. Nitrogen has an atomic number of 7, which means there are 7 protons in the nucleus, which means 7 electrons in a neutral atom. So if I put 2 here, that means I can have 5 out here, which makes 7. 1, 2, 3, 4, 5. And I want 8, so that means nitrogen can make 3 bonds. Okay? And so that's what we need to remember. Okay, so using our periodic table, hydrogen can make 1 bond. Okay, carbon can make 4 bonds. Oxygen can make 2 bonds, and nitrogen can make 3 bonds. Okay, phosphorus, which we will be looking at not so closely, and if you look at phosphorus, it's actually right under nitrogen. So this whole column has similar characteristics, so phosphorus can make the same number of bonds as nitrogen, which is 3 bonds. Okay?